that, please feel free to stop by and see me afterwards. Turn it over to you guys. Thank you.
Thank you, Carrie. Good morning. My name is Bob Stroh. I'm with Stroh Sales Associates. We're manufacturers, representatives for HVAC equipment. One of the products we represent is RenewAir, and I'm here today to talk to you about the code changes that require mechanical ventilation that have recently been implemented here in Pennsylvania. I'm here as a RenewAir representative, so obviously I have that sort of angle or that dog in the hunt, if you will. But it was not my intention to make this a RenewAir presentation. When we get into parts of it later, it'll feel like that, and I'll apologize for that. This is primarily an educational, the premises that we want to answer your questions that you may have about the recent code changes. In the course of putting together my presentation, Brian had sent me the PHRC presentation that they've been using around the state to educate builders and other parties that are in the residential construction field. And when I compared it to the slides that I have from RenewAir, especially regarding code, I thought, well, man, I won't be able to keep people awake if I use the RenewAir slides. Their slides are so much better in terms of just getting the basic point across. So I've asked Brian to deliver the presentation as it relates to codes, and he graciously accepted that. So as we go through that, I'll hand this off to Brian. Here's what I want to cover today. By the way, we appreciate you taking your time this morning. Everybody's time is valuable. I know that's a cliche, but it's certainly true in your case. This meeting is what we feel was best to address some of the questions you may have. But at the end of the day, if you came in here with questions that you don't yet answered, then we have failed. And we want to make sure that those questions are answered. So if you have questions at any point beyond the topics that we're going to discuss, please don't be shy about it. So what we want to cover here is basically why and when did codes change, and what does mechanical ventilation mean, when is it required, how much is required, and then we'll get into what my options are to provide ventilation air. Invariably, that's going to take us into the area that I am best at, if you will, and that's balanced ventilation and those devices that will achieve that. And that we'll talk about heat recovery ventilators versus energy recovery ventilators. But I also want you to leave with an idea of what impact ventilation air has on HVAC systems. And as I say, anytime you have a question, please ask me. Brian, this is where you get to show your stuff.
Thanks, Bob. Good morning, everybody. I'm Brian Wolfgang, Associate Director of the Pennsylvania Housing Research Center. I've been working with Bob as the role that I'm kind of playing today of the Chair of the Education Committee for the Builders Association. So a quick plug for that. If you're interested in learning more from the association, please respond to Carrie's survey or just reach out to Carrie or myself. We're going to be planning these at least quarterly, but we're looking to continue to offer these different seminars in the local area to members and non-members. So what we're going to talk about today is I'm just going to talk about a tiny portion of it, but it's really looking at the piece of the code change that deals with mechanical ventilation, but it's bigger than that. It's representing one of the challenges of mechanical ventilation in that here's a big range of performance that you can achieve within the code that Bob's going to talk about. He's going to focus more on balanced ventilation than some of the other options. But those other options are code compliant. But it's just important to understand that there's big differences in performance between them. A lot of times people will see code minimum as a good starting point, but again, there's just a big range of performance when you get into this. So that's what we're going to talk about. There are a lot of people in the room with a lot of expertise in this. My colleague Chris Hine is here as well. if you have questions. We have some code enforcement in the room as well, and I know we have a lot of people who've installed these systems, so to make sure to lean on the experience in the room. A little bit of a recap of where we came from with this. The codes changed last year, so we're in 2019 now. Really look at back about a little over a year ago, the recommendation was to go to most of the 2015 codes. And these new provisions, the 2015 IRC went into effect on October 1st of last year. A lot of people really didn't see that until more recently, because you had a bit of a phase-in period. So I'm going to mention this in the context of industrialized housing as well. That here we're talking about the Uniform Construction Code. That's what we look to in Pennsylvania to dictate what code books are we looking to, what are the carve-outs, what are the things we're brought in. Modular housing is regulated under a different act. It's the Industrialized Housing Act. But as of April 1st of this year, they're on the same codes. So if you're looking at what's required to have a blower door test, what's requiring this mechanical ventilation to be installed per the requirements that we're discussing today, it includes anything that's under the purview of the IRC, but also now includes modular as well. There was that phase-in period. So there was that 6-month period where if you had a contract signed before October 1st for design or construction, you had the ability to pull a permit in the next 6 months that was under the old code. But we're past that now, which is again why you may not have seen this or may not have been asked if you're an HVAC subcontractor to provide these systems yet, because we're really just starting to get into it. When we go around the state, a lot of people were pulling permits early or signing contracts early to try to avoid some of this transition. But we're past that now. So we're really starting to get into some of these requirements head on. As a recap, where are we now? Which code provisions apply? Just want to point out that there are 3 different types of code provisions within the Uniform Construction Code. That's an umbrella that you look at code provisions coming from the book, the printed book, the 2015 IRC. But then you also have legislative changes, so something that's included in the language of written law. So those tend to be focused on things like sprinklers. So sprinklers are still not required for 1- and 2-family dwellings. Stair geometry, floor protection, fire protection for lightweight systems. But then we have these amendments on the right. Those are things that change every 3 years. So the Review and Advisory Council that went through all these codes and made all these recommendations, they're starting to look at the 2018 codes on Tuesday. So we're getting right back into it for the next cycle. There are a lot of different things that make the Uniform Construction Code not just looking at this book. So that's what we've tried to point out in the seminars that this association has offered. But if at any point you have questions on this, that's what the PHRC has been training on for the past year. We'd be happy to help you out. But the fun part is you have all these different books to look to now. With mechanical ventilation specifically, we're going straight to the 2015. So if you don't have the book, that's fine. If you want to look it up online, you can view that code for free, and the tables and the language that we're going to look at in the next couple minutes, you can look at that online. Just do a simple internet search, 2015 IRC, and you can look at it through the ICC system. But you're going to the 2015 book for that. There are things that are coming out in 2006, 2009, and even 2018. That's not what we're talking about today. Those aren't having to do with mechanical ventilation. So I'm going to talk a little bit briefly, big picture, why do we need whole house mechanical ventilation, and Bob can touch on this more if there are any portions of this that I don't hit. But it's just a basic shift, and I say basic in what's on this slide, but it's obviously much more complex than that. That as the regulatory environment has changed, as what the codes are addressing has changed, we've become more energy efficient, we've become more airtight. You can really no longer rely on that passive interaction of outdoor air and indoor air. You can't rely on that outside air providing what's needed by your occupants. So we talk about letting the house breathe. You can't do that under the code anymore. You're looking now that you need to build tight, ventilate right. You're tightening up the enclosure because you're required to, and then you're ventilating because you're required to. Granted, if you've been working in high performance, you've been doing this for a long time anyway. So that design philosophy is where the codes have pushed the overall industry, but again, there are people in the industry that have been doing this to a high level for a long period of time. You have to look at what triggers the requirement to provide ventilation, and it really comes back to how tight your enclosure is. There's new language, and we talked about this in a previous seminar, that requires a blower door test. All that is a diagnostic test that's proving during the code inspection process that your enclosure, that your shell is tight. So having the requirement to have a blower door test isn't necessarily what caused you to tighten up your enclosure. It's that you now have to meet this level of 5 8 changes per hour at 50 pascals. This test, if you're not familiar with it, is running a pressurization or depressurization test. You have a fan in a central location that's sucking air out until you reach a pressure difference from inside to out of 50 pascals. While you're maintaining that pressure difference, if you run it for a full hour, the overall volume of conditioned air in the home that's coming through that front door or that central location has to be 5 times the volume of conditioned air or less. So the lower the number, the tighter your enclosure. Once you get below 5, that's really the threshold that was identified in the codes. Once you get below 5, that's too tight to rely on outside air or fresh air coming in to do everything the fresh air does for your occupants, diluting pollutants, providing a lot of that healthy environment and improving your indoor air quality. So once you get below 5, that's where you're now required to provide mechanical ventilation. So if you look where this is coming from in the book itself, you can look at chapter 3, so 3 and 3.4. Very briefly, it says, if you're below 5 air changes per hour on a blower door test, then you have to provide mechanical ventilation. Well, in Pennsylvania, it was amended so that you have to be below 5 air changes per hour on a blower door test. So effectively, instead of going directly and saying you're required to have mechanical ventilation, they kind of went around it, but that's where we are. So if the air tightness requirement is not to exceed 5 ACH 50, and it is in Pennsylvania, again, you're required to provide ventilation. So where do you go to try to understand how much you need to provide and what are the constraints on how you provide it? You have to go to chapter 15 in the IRC. So again, if you want to dig into the code requirements and you're not sure where to go, just jump on the internet, search for the 2015 IRC, jump into chapter 15, 1507.3. It's not a very big section in terms of what they're specifically requiring and what they're not allowing you to do. They give you a pretty wide range of options, in my opinion, for providing this, for providing mechanical ventilation. And that's what Bob is going to highlight in terms of system options. They're not necessarily, we get a lot of questions when we're out on the road that, okay, now we have to provide ventilation. Do we need to provide an HRV or ERV? No, you don't need to. You may want to, and Bob's going to try to tell you why there's a benefit to that if you can fit it in the budget. But ultimately, there are more options than just that. So big range of cost options, big range of performance options. So again, you jump to chapter 15, I want to highlight a couple of these sections, but I want to focus on really the core requirement for volume, which is, there's a table in chapter 15. This first one is really what outlines those boundaries, those constraints that allow you to figure out what type of system you're providing. So under system design, the whole house system shall consist of one or more supply or exhaust fans or combination. Right there, it's defining your 3 main options. One or more supply fans, one or more exhaust fans, or combination. Combination being a balanced system. So it's laying out those 3 different options. They're saying you can use local exhaust or supply fans, and Bob will highlight what that means if you go that route. And then also highlighting outdoor air ducts connected to the return side of the air handler shall be considered supply ventilation. So again, they're highlighting all the different options. A couple of other things in here that are unique. You do have to provide a manual override, and maybe Bob can speak to this a little bit for these different systems. That's presented some issues because when you start getting into some of these more complex systems in a home, you have to try to communicate to the homeowner the intent behind it so they understand how to operate it. Anytime you put in an expensive system that you're relying on to provide adequate indoor air quality, and they readily have the ability to shut it off, that presents a challenge. So that's one thing that has to do more on the people side. But really where the rubber meets the road is when you look at the ventilation rate, what's required. And what this is not is an ASHRAE standard. This is not ASHRAE 622. In 2018, in the code cycle that they're starting to review next week, that's when you're going to start to look at the IRC aligning with ASHRAE. The methodology that's used for this is different. It's older than the current ASHRAE standards. So if you are working with somebody who's referring to an ASHRAE standard to try to design the ventilation, I'm not going to say that that's not allowed, but there are times when it doesn't necessarily align and you have to have conversation with the code official. The requirements in this section are saying that the ventilation system shall provide outdoor air at a continuous rate not less than what's in this table. We'll come back to that in a second. You do have the option of running it intermittently. If you're running it intermittently, there are some factors that you have to then multiply your rate by, but you are required to have this operating not less than 25% of each 4-hour segment. So you can't have it turn on for 12 hours, turn off for 12 hours. It needs to be a little bit more spread out throughout the day. But this table is, again, where you're finding what type of volume am I needing to provide and what's it based on. And it's really based on the size of the home and the predicted number of people that live in the home. So the size of the home over here and these ranges of dwelling unit floor area, and then the number of bedrooms is really a predictor of how many people are living in that space. You can see that this range goes up pretty high. You're going to mostly see a lot of the residential that's built in this area, at least, is going to be in this upper left corner here of the table. But these are continuous rates. So, a 2,500 square foot 4-bedroom home has to provide 75 cubic feet per minute of ventilation air continuously, 24 hours a day. How you provide that, again, is up to you within those constraints that were outlined in that previous code section. You're either providing an exhaust fan that's pulling 75 cubic feet per minute or multiple exhaust fans. You're either providing supply at 75 CFM, or you have a balance system capable of running at 75 CFM. So that's sort of your baseline with this. And then again, if you want to work with some more complex controls to say, I want it to run 50% of the time. Again, it's simple as multiplying your rate by 2. So if you want that to run 50% of the time, you're going to have to provide a system that can run at 150 CFM for 50% of the time. You have to have the controls that automatically turn it on and off